Alright, now we're looking at the side angle side similarity theorem. Basically, if you look at this shelter right here, we have two different size triangles, and we want to know if these two triangles are similar, because otherwise it won't really work so well. The side angle side similarity theorem tells us that we need to have one set of corresponding angles that are congruent, and then the sides have to have that proportionate kind of fit to it. So if you look in this problem, there's a couple things going on. First of all, angle F is congruent to angle A, and you can see that because they're both 53 degrees. Then if you look, we have a side here and a side here. We have a side over here and we have a side over here that they give us. So what we want to do is compare FG to AB because they're both the shorter sides, and we also want to look at FH compared to AC. Okay, so for the first one we've got 6 to 9, which reduces to 2 to 3. And for the second one we've got 10 to 15, which if we divide both top and bottom by 5, we get 2 to 3. So in this case we can say that triangle FGH is similar to triangle ABC by side, side, side. I'm sorry, not side, 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 but side, angle, side, triangle similarity. Okay? We've got our side, our angle, our side. Good? Let me switch this. So again, we want to know, are the two triangles similar, basically? So we did that. We look at A and F, and they're both 53, so therefore the two angles are congruent. The shorter sides, they did 3 over 2, I did 2 over 3. And so we get 3 to 2 for both. I got 2 to 3 for both, but it doesn't matter. The lengths of the sides that include A and F are proportional, and so therefore by the side angle side similarity theorem we can state that the two triangles are similar. Alright, here's another one. So, sorry, having a little bit of difficulty here. We know that these two angles are congruent because they're vertical angles, so we can state that angle ACB is congruent to angle ECD. And then remember, we want to compare short to short and then bigger to bigger. So BC matches up with CE in this case. In other words, the small side of this triangle matches up with the smaller side of that triangle. So we would say this is 9 out of 15. Both of those are divisible by 3, which gives us 3/5. And we would say that AC over CD in this case, because those are the bigger sides, would give us 18 over 30. 18 and 30 are both divisible by 6. 18 divided by 6 is 3. 30 divided by 6 is 5. So therefore we can state that triangle, and be careful with the writing here. If I call this, let's call this ABC. If I say ABC, A matches up with D, B matches up with E, and then we end with, C. So ABC and DEC are similar. We would say that they're similar by side angle side triangle similarity. Okay? And again, we've got the ratio of these two sides is 3/5. For these two sides it's 3/5. And we know that these two angles are congruent, so the two triangles are similar by side angle side similarity. Here's another one we can do using side angle side similarity. We know angle R is congruent to angle N because they're both right angles, and all right angles are congruent. We know SR is the smaller one here, so it matches up with this, so it would be SR over PN. That gives me 24 out of 18. Both of those are divisible by 6. Ooh, even bigger. Let's see. By 6 for sure. 6 gives me 4 here. Divide by 6 gives me 3. Then we want to look at RT and compare that to NQ. That gives us 28 to 21. Both of those are divisible by 7. Again gives us 4 to 3. So we've got our side angle side here. We can state that these two triangles are similar by side angle side triangle similarity. Those are both 4 over 3. Those angles are congruent. Side angle side similarity. One more, I think. Let's see. So we've got this triangle here. We've got that triangle there. We know that there are right angles there. So we can say that angle XZW is congruent to angle XZY. Okay, and then we just need this side, and then that side and that side. So we need, oh, we could do this both ways. Oh well, I'm going to use side angle side. So we can state that the short side on this one, which is XZ, matches up with the short one on this one, which is ZY. That gives us 12 to 9. Both of these are divisible by 3, so that gives us 4 to 3. And then the long leg on that triangle, which is WZ, matches up with the long leg here, which is XC. That gives us 16 to 12. And so we get 4 to 3 here. We can state that these two triangles are similar now by side angle side triangle similarity. We could have also looked at WX over XY and gotten 20 out of 15. Both of those are divisible by 5, which gives us 4 to 3. So if we'd use this information right here, that would give us side, side, side triangle similarity. If we use this information right here, that would give us side angle side triangle similarity, which is what I did here. So they did it with side angle side, but you could have done it, you could have done it with side, side, side here, or we could have done side angle side. And we're done. Thanks.